Hey everyone, and welcome. Today, we're diving into one of the biggest questions there is. Why? But we're looking at it through a really fascinating lens. How are we trying to teach artificial intelligence to understand something as fundamental as cause and effect? This is the question, right? It's at the core of everything we do. It's the hunt for causality. And as our AI gets smarter and smarter, it turns out that teaching a machine how to answer this is one of the toughest challenges out there. All right, so here's how we're going to break this down. We'll start with the basics of what causality even is. Then we'll look at two totally different ways AI tries to figure it out. First, the old school way, searching for a fixed map of reality. And then a newer, way more adaptive approach. We'll see how it actually learns. And then we'll get into this wild idea that causality isn't just one thing, but a whole bunch of things. So what is causality, really? At its most basic, it's just the link between one thing and another. It's the idea that one event, the cause, makes another event, the effect, happen. It's the because that connects all the dots in our world. Okay, so the first major approach in AI thinks about causality like it's a fixed part of the universe. The goal is to basically create a perfect, complete map of how everything is connected. A single source of truth that's just out there waiting for us to find it. And you gotta pay attention to the words they use here, words like recover and true causal graph. This way of thinking assumes that there's already one single correct diagram of cause and effect that exists, and the AI's job is to just dig through enough data to uncover it. And this whole idea is built on one giant assumption, that the rules of the universe don't change. It's a belief that whatever patterns we saw yesterday are going to hold through tomorrow and the day after and forever. But, what if they don't? What happens when the world changes? And that question, what if the world changes, is exactly what leads us to a completely different philosophy. This second approach, seen in a system called NARS, isn't trying to find a static map at all. Instead, it wants to build a dynamic compass, a tool that can help it navigate a world that's always changing. The starting point for NARS is something called AIKR, and it's basically the exact opposite of the traditional view. It assumes that the AI will never have all the information it needs, so its goal isn't to find some perfect final truth. No, its goal is to adapt and make the best decisions it can with the limited knowledge it has at any given moment. And this slide just lays out the difference perfectly. On one side, you have an AI trying to discover a permanent set of laws. On the other, you've got an AI that learns flexible rules, and it fully expects that new information might make it change its mind tomorrow. It's like the difference between a historian reading old maps and a scout exploring new territory. So if this system isn't just looking for a pre-existing map, how does it learn to find its way around? Well, the answer is actually incredibly human. It learns by doing. It learns by taking action and seeing what happens. To make this really concrete, let's just imagine an AI system like NARS running into a TV remote for the very first time. It has absolutely no idea what this thing is or what it does. So it performs an action. Researchers call this an intervention. It pushes a button. Then it observes. It sees a little light flash on the remote. And from that one experience, it forms a tiny, low-confidence hypothesis. It thinks, maybe pressing this button causes that light to turn on. It's building its entire understanding from the ground up. Now, this is where this adaptive approach really gets cool. Let's say it presses the button again. The light flashes, but the TV doesn't turn on. Nothing happens. A system that's looking for one single true rule might just crash, right? It's an error. But NARS doesn't see it as a failure. It just sees it as new data. So it updates its guess. It thinks, okay, maybe something else is needed here. It might investigate and figure out, oh, the batteries are missing. So its rule gets smarter, more detailed. It's no longer pressing the button causes the light, it's pressing the button plus having batteries causes the light. Its understanding gets deeper with every single interaction. It can even take it a step further into something called counterfactual reasoning. It can think about what didn't happen. It can reason, the light didn't flash because the battery was missing. But if the battery had been there, then pressing the button would have made the light flash. This ability to imagine different realities is an incredibly powerful tool for learning. All of this leads to this really deep and interesting idea at the heart of the NARS system, that causality isn't just one simple thing. It's what the creators call a fat concept. So what does that mean? It means that what we mean by the word cause can actually change depending on the context.
It's not just about predicting that A leads to B. It's a much richer, much more flexible idea than that.
Think of causation like a recipe with different ingredients. Sometimes the most important ingredient is reproducibility. Can you make it happen again? Other times, what matters is controllability. Was it a deliberate action? For a physicist, the time between two events might be critical. For a lawyer, necessity might be the whole game. NARS can weigh all these different factors depending on the problem it's trying to solve. And this is the bottom line. This is why this matters. The real world is messy. The way a physicist thinks about causality is just different from how an economist or a doctor does. An AI that can adapt its very definition of cause is so much better equipped to handle all that complexity than one that's stuck looking for a single universal law. And that leaves us with this final big idea to chew on. As we build these increasingly intelligent systems, we have a choice to make. Do we want an AI that's searching for a single, rigid map of reality, or do we want one that learns how to use a dynamic, adaptive compass? The answer is going to shape not just how our machines think, but how they help us make sense of our own complicated world.